Namaste everyone and welcome back to the channel. I am your Java programming teacher and today we are going to dive into a super exciting and important topic, Java multithreading and concurrency. Have you ever wondered how your computer can do so many things at once, like playing music, browsing the internet, and downloading files, all simultaneously? That is the magic of multithreading. In this 5-minute animated whiteboard tutorial, we will break down this complex topic into simple, easy-to-understand concepts. We will learn what multithreading is, why it is so crucial for modern applications, and how you can implement it in your Java programs using both the thread class and the runnable interface. We will also look at a practical example and discuss some common mistakes to avoid. By the end of this video, you will have a solid foundational understanding of how to make your Java applications more responsive and efficient. So, grab your virtual notebooks and let us begin this amazing journey. Alright, let us start with the very first core concept. What exactly is a thread in Java? Imagine you are in a kitchen and you need to prepare a big meal. If you try to do everything yourself, chopping vegetables, stirring the pot, baking bread one after another, it will take a very long time. But what if you had multiple chefs, each working on a different task simultaneously? That is exactly what threads do in a program. A thread is like a lightweight subprocess, an independent path of execution within a program. Your main application always runs on one thread, called the main thread. When we talk about multithreading, we mean creating and managing additional threads to perform tasks concurrently. The simplest way to create a thread is by extending the thread class. You override its run method, which contains the code that the new thread will execute. Then, to start the thread, you call its start method. Remember, never call run directly, always start. While extending the thread class works, a more flexible and generally preferred way to create threads in Java is by implementing the runnable interface. Why is it preferred, you ask? Well, Java does not support multiple inheritance for classes, meaning a class can only extend one other class. If your class already extends another class, you cannot extend thread directly. However, a class can implement multiple interfaces. So, by implementing runnable, you separate the task, what needs to be done, from the thread, how it is done. You implement the run method in your class, just like before. Then, you create an instance of your runnable class, pass it to a thread constructor, and finally, call start on that thread object. This approach promotes better code organization and reusability. It is a very important concept to grasp for efficient multithreaded programming. Now, let us put these concepts into practice with a simple, hands-on example, a concurrent counter. We will create a counter class with a simple increment method, and then multiple threads will try to increment this counter. Observe what happens. We will define a counter class with an integer variable count and a method increment that increases count by 1. Then, we will create a runnable class, say increment task, that calls the increment method of our counter object repeatedly. In our main method, we will create several increment task instances, each running in its own thread. When we run this, you might notice something unexpected. The final count is often not what you expect. If 10 threads each increment the counter 100 times, you would expect a final count of 1000, right? But it might be less. This leads us to our next point, common mistakes and how to fix them. This unexpected behavior in our concurrent counter example is due to a very common issue in multithreading called a race condition. A race condition occurs when multiple threads try to access and modify a shared resource, like our count variable, simultaneously, leading to unpredictable results. Imagine two chefs trying to add an ingredient to a bowl at the exact same moment. One might overwrite the other's action. A simple way to prevent race conditions for shared data is by using the synchronized keyword in Java. When a method or a block of code is synchronized, only one thread can execute it at a time. This ensures that the shared resource is updated correctly. For example, if we make our increment method synchronized, each thread will wait its turn to access and update the counter, guaranteeing the correct final result. Other common mistakes include forgetting to call start on your thread, which means the run method will just execute on the main thread, or using thread.sleep without understanding its implications, as it pauses the current thread, not necessarily all threads. Alright, we have covered a lot in just 5 minutes. Let us quickly recap the key takeaways from today's session. We learned that Java multithreading allows your programs to perform multiple tasks concurrently, making them more responsive and efficient. We explored two primary ways to create threads, by extending the thread class and by implementing the runnable interface, with runnable being the preferred approach for better design. We saw how to start a thread using the start method and define its execution logic in the run method. Crucially, we understood what race conditions are and how the synchronized keyword helps us prevent them, ensuring data consistency when multiple threads access shared resources. Remember, practice is key. Try creating your own multithreaded programs. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming tutorials. Keep coding, keep learning, and I will see you in the next video. Jai Hind.